Today, we are diving into one of nature's most powerful and frankly awesome forces, the tropical cyclone. Now, you might know them as hurricanes or maybe typhoons, but at their core, they're all the same beast. These colossal, spinning engines of destruction born over our planet's warmest oceans. But have you ever really stopped to wonder how they form? I mean, what's the exact recipe? What ingredients have to come together in just the perfect way to create something so immense? Well, that's what we're going to figure out today as we break down the science of the superstorm. All right, so it turns out there are 5 absolutely essential ingredients in this cyclone recipe. We've got the fuel, the moisture, the spark, the structure, and of course, the spin. We're going to go through them one by one, and you'll see how they all have to work together perfectly. So, first up, let's talk about the foundation. Before you can even think about building a storm, you need the 2 most basic ingredients on Earth, water and air. But here's the catch. It can't be just any water and air. They have to be just right. The first, and maybe the most critical ingredient, is the fuel. And that fuel is incredibly warm ocean water. The magic number to remember is 26.5 degrees Celsius. That's about 80 degrees Fahrenheit. The ocean's surface has to be at least that warm. This is the raw thermal energy that the storm needs to even begin to form. And here's the thing, that warmth can't just be some thin little layer on the surface. Nope. It has to go deep, down at least 50 meters, or more than 160 feet. Why? Because this creates a massive reservoir of heat. As the storm gets going, its winds churn up the ocean, and it needs to be able to keep pulling up more of that warm water to feed itself. Okay, ingredient number 2 is moisture. Lots and lots of it. We need a really humid atmosphere. As all that warm, moist air rises off the ocean, it starts to cool down, and the water vapor condenses, forming clouds. Now this is where the real magic happens. It's a process called latent heat. When that vapor turns back into liquid water droplets, it releases a ton of energy. This heat is the true engine of the storm. It warms up the air around it, which makes it even lighter, causing it to rise even faster. And that just supercharges the whole system. So we've got our fuel and our engine. But now we need a catalyst. We need the right conditions to actually get the storm started, and this is just as important, to allow it to hold itself together while it gets stronger. And here's a really key point. These massive storms don't just pop into existence out of thin air. They need a spark to get them going. This is usually some kind of pre-existing weather disturbance. Think of just a simple cluster of thunderstorms hanging out over the ocean. That little disturbance provides the seed, a spot of low pressure that the bigger storm can start to organize itself around. Now, once that little storm starts to form, it needs a nice, calm atmosphere to grow up in. And that's where something called wind shear comes into play. Wind shear is basically just a change in wind speed or direction as you go higher up. In a low wind shear environment, like you see on the left, the storm can build itself straight up, like a strong, organized tower. But high wind shear? Oh, that's a total storm killer. It literally rips the top of the storm away from its base, tearing the whole thing apart before it ever has a chance to get strong. Okay, so we've got our fuel, we've got our moisture, we've got a spark, and we've got a stable atmosphere for it to grow in. Now it is time for the final, almost secret ingredient. This is the one that gives a cyclone its iconic, beautiful, and terrifying swirling shape. And that secret ingredient is the Coriolis effect. It's not really a force you can feel, but an effect that happens because the Earth itself is spinning. So as all that air tries to rush in towards the low pressure center of the storm, our planet's rotation deflects it. It gets pushed to the right in the northern hemisphere and to the left in the southern. And that little push is what starts the storm's massive signature spin. And this effect explains something really, really cool. Why you never see hurricanes or typhoons forming right near the equator. See, the Coriolis effect is weakest at the equator and gets stronger as you move towards the poles. So right around the middle of the planet, there just isn't enough of that deflecting effect to get the rotation going. The storm simply can't organize. It's like a natural built-in hurricane free zone. Pretty amazing, right? So let's just recap the whole recipe one more time. You need 1, warm, deep ocean water for fuel. 2, a super moist atmosphere for that latent heat engine. 3, some kind of little weather disturbance to act as a spark. 4, low wind shear so it can build a stable structure, and 5, the Coriolis effect to give it that all-important spin. When all 5 of those things line up just right, well, that's when you get a superstorm.
And that brings us to a final, really crucial question to think about. We've just established that warm ocean water is the #1 fuel for these storms. So as our planet's oceans continue to get warmer and warmer, what does that mean for this recipe in the future? Are we basically making the most important ingredient more and more available? It's definitely something to think about as we continue to watch these incredible forces of nature.
Subscribe to Fun Time with Samay for fun, facts, and educational videos every week.